Hey, this is Mr. Dan with Touch Technologies. We're going to be talking about Sheerpower data types and variables. By the way, this particular talk assumes that you have programmed using a programming language of some sort, whether JavaScript or Java or whatever, PHP, whatever it is, but you programmed in something. So we're not trying to teach you programming concepts. We're trying to teach you how to use Sheerpower programming concepts. Okay, so Sheerpower, of course, has data types and variables, like all languages do, and we have what are called reals, strings, Boolean, integers, and dynamics. You'll notice we're not using the word float here. That's because our reals are not floating data types. They are real data types. They are designed to keep perfect precision so that we don't have penny rounding errors. The default type of data for Sheerpower is indeed a real data type. And they're pretty cool. They support 18 digits to the left of the decimal point, which is a billion, and 16 digits to the right. And again, they're stored in such a way they maintain perfect precision. So if we take a look at one of them, we can say something like tax is equal to 11.5, print, the tax is, right? Print the tax. Run that program, the tax is 11.5. Pretty simple. And if we want to do some kind of operation on it, we can say print tax times 12345.6789, right? And then you get the answer, of course. So that's what a real looks like. Pretty simple. The variable that ends in a $sign by default is a string, and a string is, just like it is in other languages, a string is a sequence of characters or byte values. Sheerpower strings can be as long as 2 billion characters long, so pretty good size. And the strings in Sheerpower can also contain hidden metadata, which we'll be talking about in another talk, that really helps optimize string operations. Sheerpower string operations are very, very fast. And let's take a look at some strings real quick. So like name dollar equals Sally Sue. Okay, that's a string. Print name dollar has a tax of tax. Okay, we run that. Okay, Sally Sue has a tax of 11.5. So strings are pretty easy to understand. All right. We also have variables if they end in a question mark. That's a Boolean. A Boolean is a true or a false. Typically you use Booleans with if statements. If something's true, then you want to do something, else you want to do something else, and so on. Let's try that. Let's say if tax is greater than 11, then is big, question mark. Equals true. Good enough. And we'll say if is big, question mark, then print the tax of tax was big. And we run that, and oops, spelled it wrong. Good job. And we just close it over here. By the way, this is a really small program, but everything in Sheerpower is instant. The time it takes to compile and run is virtually always under a second. We compile at around 500,000 lines of code per second, so really fast stuff. Now let's take a look here. If a variable ends in a %, then it's an integer and it has no decimal digits. This type of data we don't use it very much in business applications. I rarely bother to use integers at all for anything. There are very tiny performance benefits in using integers over the real type, but they're very small benefits. But let's take a look at one. We'll say state tax % is equal to the tax. Okay, and remember tax is 11.5, so if I say print the state tax is, and then I take a look at it, state tax %, what do you think that's going to be? Well, this has to be this is an integer, so it's going to take the 11.5, it's going to notice it's at 0.5, and it's going to round up. So when we take a look at that, it's going to say, oops, state tax is 12. Typo error there. Let's go fix that and run it. State tax is 12. Okay, very good. Now, what if instead the tax was 4, right, 11.4? The state tax is 11. So you can see it's done the appropriate rounding and all that kind of good stuff. So it's pretty nice. Sheerpower also supports variables that are dynamic. Those are variables that will take on the data type of however they're used. And they're pretty interesting. We put them in because they were useful in doing a lot of database operations where at runtime you don't know the data type of a given variable that's in a table because the table is external to the code. So we had to develop these dynamic variables. They're somewhat similar to C++ auto, AUTO data types. They share a little bit with that. Let's take a look at it. We'll say declare dynamic. You have to use a declare statement to create one of these dynamics. And we can also use declare statements, by the way, to declare things as reals or declare them as strings and booleans and stuff. Let's declare dynamic special. All right, so now I can say special is equal to 45, print special plus 100. Let's do that. And we'll run this, and you can see 145. Well, there's a 45 and there's 100, so 145. Good, simple enough. Now I can say print special plus is a lot. And you'll notice that I'm concatenating special as if it's a string to is a lot. When I run that, it says 45 is a lot. So it actually dynamically changed the value of 45 to a string and then worked with it. We haven't seen yet. Declare dynamic dynamic special. There we go. Special equals 45. Print special plus 100. Hey, what are we going to see? Not surprising, we see 145. We'd expect special equals hello there. That's a string, isn't it? Print special plus space plus the name. How about that? Hello there, Sally Sue. So in this case, special is now working as a string. So specials are a dynamic data type. The declare statement allows variables to be declared also, so you can override the variable naming convention. Let's take a look at that. Say the declare string of, let's say XYZ. XYZ. You notice there's no $sign at the end. It's okay, it's still a string. XYZ is equal to Freddie. Print the other name is XYZ. Let's run that. The other name is Freddie. So you can see XYZ is behaving as a string because we declared it that way. And you can declare things as integers and reals and booleans and so on. So that's all very cool. Variable names in Sheerpower are case regardless. That means total, it doesn't matter, upper, lower case, mix. It's the same variable. And we do that because it eliminates a lot of code confusion. A lot of people have trouble when they're writing code because they would make a tiny little mistake and what's upper, what's lowercase, and it gets messed up. But it's okay for us. Let's take a look here. Here's XYZ. I'm going to say other name is XYZ. See, capital Y here, right? Run it. Perfectly fine. Works just the same. There's no difference. That's also, by the way, for things like the print statement, print, print, like that. No problem. Works just fine. So this greatly simplifies maintenance later on. And that's the end of this particular presentation. We'll be giving some more advanced use of variables and data types